Alright, so this will be the Chapter 2 review. Like the review for every chapter, if you could do all the problems on the review, you should be able to do all the problems on the test. I never try to make any problem on the test harder than anything on the review, and essentially the instructions for the test questions will be the same as the instructions for the review questions, except they'll be in a different order. So there'll be a problem on the test that says use the power rule to find the derivative, but it's probably not going to be problems 1 through 4. Maybe it'll be problems 8 and 9. So the test will be a little bit shorter. So if a instruction has 4 parts on the review, it won't have more than 4 parts on the test, but it'll probably have 2 or 3 parts. So let me just go ahead and just do this, and I'll do the even and the odd problems as opposed to how I do in the non-review videos. So using the power rule, that's just multiplying the exponent by the coefficient and lowering the exponent by 1 to find the derivative. And this I can do in my head. So for the first term, I'm going to multiply the 4 times 2 and get an 8, and lower the exponent by 1 and get an 8x cubed for the first derivative. The second term, I'm going to multiply the 3 times the negative 4 and get a negative 12, lower the exponent by 1 to x squared. The third, I'm going to multiply the 2 by the 2 and get a 4, lower the exponent by 1 and get an x to the first. The second to last term has an exponent of 1. I'll multiply the 1 by the negative 4 and get a negative 4, lower the exponent by 1 and get an x to the 0. And the last piece doesn't have an x, so it's a constant. It has a derivative of 0. I wrote a couple things here that I probably shouldn't have. This term I should have just written as 4x. And this term, because x to the 0 is 1, I should have written as just minus 4. So a better answer than what I have above here is g prime of x, the derivative is 8x cubed minus 12x squared plus 4x minus 4. And when we use the product rule, we definitely want to pull out common factors. When we did the power rule, we got we didn't do as much factoring. If you want to here, there is a common factor of a 4. This would be probably how I'd leave my answer. But if you did the extra step because you noticed there was a common factor of a 4, and you factored out that 4 and you wrote 4 times 2x cubed minus 3x squared plus x minus 1, that's fine. You could actually give a crack at factoring this using synthetic division. I'm not sure that it factors, and we definitely are not going to factor a cube unless it's a really special cube. So again, this is probably where I'd leave my answer for problem 1. Problem 2 wants me to use the power rule again, but it's not ready for the power rule because the power rule doesn't work when there's fractions. But if we have terms that have fractions and there's only a single letter in the denominator, it's not hard to write the problem without that fraction, so you could use the power rule. If I left the problem written in the form that it's written, I'd have to use the quotient rule, because when you have the x in a denominator of a fraction, you need to use the quotient rule. So 2 of the pieces need to be rewritten, and I'm going to rewrite them by making them non-fractions. I'm going to take the x's that are in the denominators, move them up to the numerators, and when I do that, I have to change the sign of their exponent. It's easy on that term to see that it changes to 2x minus 2x to the negative 2, but that x, there's an implied exponent of 1, so when I change it, it turns to 3x to the negative 1. Now that I have the 3 individual terms written without fractions, I can go and take the derivative. So for the first derivative, I'm going to multiply the negative 1 by the 3 and get a negative 3. And I'm going to lower the exponent by 1 and get a negative 2. So that first term has a derivative of negative 3x to the negative 2. The instructions said to only write your answer with positive exponents. And to make that negative 3x to the negative 2 have a positive exponent, I need to create a fraction and move the x down to the denominator, but not the negative 3. The second term, for its derivative, I'm going to take the exponent of minus 2, multiply it by the minus 2 that's already in front of the x, and lower the exponent by 1, and minus 2 minus 1 is minus 3. This double negative will turn into a plus. Then I get 4x to the negative 3 power, because minus 2 minus 3 is negative 3. And similarly, I don't want a negative exponent in my answer, so I'm just going to rewrite that as plus 4 over x cubed. And then the last piece, I wouldn't even show any work. In fact, if you can go from the original problem to the answer because you could do it in your head, that's completely fine. You don't have to show all the work that I'm showing. I'm just showing the work just in case you forgot how to do this in your head. The last piece, I'm going to take the exponent that wasn't written, that was implied to be 1, and go positive 1 times 7, and then x to the 1 minus 1 power. That's going to give me plus 7x to the 0 power. And since x to the 0 power is 1, that's just going to be plus 7. And that's where I'd leave my answer for problem 2. Problem 3 is written with a radical, and square roots can always be written as 1/2 powers. And before I did the derivative for problem 3, I'd rewrite it with a fraction exponent. Now I can use the power rule. And I don't write f prime of x until I multiply the exponent by the coefficient and lower the exponent by 1. So now I do the power rule. I'll do f prime of x is 1/2 times 3. And I'm going to lower the exponent by 1. And instead of writing minus 1, I'm going to write minus 2/2, because 2/2 is equal to 1. This is going to give me f prime of x. When you multiply a fraction by an integer, you multiply the numerator by that integer. So that's going to give me 3/2. And then you get x to the negative 1/2 power, because 1/2 minus 2/2 is negative 1/2. I want to make the negative exponent positive by moving it down to the denominator with the 2. And if you chose to stop here, it's okay. It's just, if the original problem doesn't have a fraction exponent, you usually change the fraction exponent back to the radical. And the 1/2 power is always something you could change to a square root. So this right here is probably the best answer for problem 3. But this is an absolutely okay answer. It's okay to have fractional exponents. If this was your test question, if you got all the way down to here and stopped, I'd probably go minus 1. If you got down to here and stopped, I'd probably write the answer that I think the best answer is, but I wouldn't take off points. All right, so the last one in this grouping where I have to use the power rule. In problem 4, again, the power rule doesn't work so well when you have an x in the denominator of a fraction, so I need to rewrite this. And this is a special problem because generally, if there's an x in the denominator of a fraction and more than one term in the numerator, it doesn't make sense to make multiple fractions out of the one fraction. But when there's only a monomial in the denominator, I can absolutely make the problem into multiple fractions, because now these fractions are all reducible. For each of those 3 fractions, I can rewrite them so they don't have an x in the denominator, so I'll be able to take the derivative. So now I'm going to reduce. For this first fraction, I'm going to cancel this x with one of the 2 x's from the x squared, and that term is going to turn out to just be 2x. I'm going to emphasize it's 2x to the first power. The middle piece, the x's cancel. I'm just left with a 3. The last piece, I need to get the x out of the denominator. There's nothing to cancel with, so I'm going to move it up to the numerator and change its exponent from the positive one that was there but not written to the negative one, because when you move an x from the denominator to the numerator, you change the sign of its exponent. Now I'm going to take the derivative. Since I have the x's out of the denominator, I'm going to do f prime of x. For the first one, I'm going to go 1 times 2, lower the exponent to 0. The middle piece has the derivative of 0 because it's constants. Constants have the derivative of 0. And then the third piece, I'm going to take the exponent minus 1, multiply it by the minus 8 that's already there, lower the exponent by 1. Minus 1 minus 1 is minus 2. Almost done. And I definitely have more work shown than you actually have to show. First piece, I'm going to multiply the 1 times 2 and get a 2. This x to the 0 power is equal to 1, so it's 2 times 1, which is just 2. Middle piece, 0, I don't need to write. Last piece, the 2 negatives multiply out to be a positive, so I get a positive 8. And I want the exponent to be positive, so I create a fraction and move the x down to the denominator of that fraction. So the best answer that follows kind of the instructions that we want to find the derivative using the power rule, which I did by rewriting the problem. The power rule is multiplying the exponent by the coefficient, lowering the exponent by 1. So I used the power rule after I rewrote the problem, and then the instructions also said write your answer without negative exponents, which I did for that last term. Alright, so that's number 4. 5's a new kind of problem. It's not very hard, or it's not any harder, even though there's multiple parts to it. So part A for number 5 wants me to find the slope of the tangent line at the given value of x. So my answer to 5A, I'm going to say the slope is m equals, and I get the value of a slope by plugging a value of x into the derivative. I'm given a value of x, so I'm going to find the derivative and plug that value into the derivative. Now, you could get the slope by using your calculator. So I could, on my calculator, go y equals, clear out the function that's in here, and go 3x squared plus 5x. Since I'm doing this at x equal to 2, I'm just going to do zoom standard. It's going to sketch a graph to me. It's a parabola. Then if I do second calc, go down to option 6, dy dx, type in the number 2. It's going to give me the slope. The slope is going to be 17. So my answer for 5A is going to be 17. If you did that on a test and you didn't show any derivative work, you'd lose some points. Definitely, maybe all the points, because I want you to do the calculus. And so the calculus to get this answer is to find the derivative. F prime of x, the derivative of 3x squared is 6x. The derivative of 5x is 5, so the derivative is 6x plus 5. The slope that this 17 is, you just take the value of x that's given, and you have to have a value given the way this question is worded. You just take the value of x that's given and plug it into the equation, into the derivative for x. And that's how you get the 17. So that's part A. Part B, it wants to find an equation of a tangent line. So ultimately, when I answer part 5b, my answer is going to be y equals mx plus b, and the m is 17, so it's going to be y equals 17x plus or minus some number. And in order to do part B, to find an equation of any line, I need a point and a slope. And the slope I got from my work in part A, the x-coordinate of the point I got from the problem itself. The y-coordinate of the point, I need to plug 3 in for x. So I'm going to go f of 2 equals 3 times 2 squared plus 5 times 2. This is 3 times 4 plus 10, which is 12 plus 10, which is 22. So the y-coordinate of the point is 22. This you could also get on your calculator. On my calculator, to get that 22, I'd go second calc, hit enter on value, type 2, and hit enter, and it gives me the y equals to 22. So now I have the x and the y coordinate of the point and a slope. I'm going to use the equation y minus y1 equals m times x minus x1 to get the answer completed that I started. So y1 is going to be 22, so I'm going to go y minus 22 equals m, which is 17, times x minus x1, which is going to be 2. This is going to give me y minus 22 equals 17x minus 34 when I clear the parentheses on the right side. I'm going to add 22 to both sides, and that's going to give me my answer. The left side I get a y, the right side I get 17x minus 12, because 34 and 22 have opposite signs, so I subtract them and take the sign of the larger. And in my answer, I just needed to finish it up with that minus 12, because I basically knew most of the answer. I just didn't know all the answer because I didn't know the y-coordinate of the point. 6 is similar, but it's in some sense the part B I could shortcut it, but I won't shortcut it on the review. But if you remember the shortcut, you can use a shortcut. So for 6, I'm given an equation without a value of x because I don't need it for here. So again, part A wants me to find well, actually part A wants me to find something different. It wants me to find a value of x where the tangent line is horizontal. So my answer to 6a is going to be x equals to something. And we did this a bunch of times in the chapter. To answer this question, you have to do two things. So for 6a, you have to first find the derivative. And then solve the derivative equal to 0, because the values of x where tangent lines are horizontal is where the derivative is 0, because tangent lines horizontal means the slope is 0, and when you set the derivative equal to 0, you're finding the value of x where the slope is 0. So the part A's, we've done a bunch of these, so I'm going to do the derivative. F prime of x, the derivative of 6x squared is 12x. The derivative of minus 24x is minus 24. The derivative of plus 8 is 0. Now I'm going to take that 12x minus 24 and set it equal to 0. So I'm going to add 24 to both sides and get 12x equal to 24. I'm going to divide both sides by 12 and get x equals 24 over 12. And that's going to give me x equal to 2. So that's the answer to 6a. Now I'm going to move on to 6b. 6b wants me to find an equation of a line. So my answer for 6b is going to be y equals, and I'm not going to write as much as I started to do for the last problem because it's a simpler right-hand side. So I'm trying to find the equation of a tangent line, and in order to find the equation of any tangent line, I need a point and I need a slope. The x-coordinate of the point is 2. The slope is 0 because horizontal lines have a slope of 0. To finish this problem up, I need to get the y-coordinate of the point. To get the y-coordinate of the point, I take the x-coordinate and plug it into the original function. So I go 6 times 2 squared minus 24 times 2 plus 8. There's kind of two ways to get it on my calculator. I can get it from the main screen, or I can get it from the y equals graphing screen. From the main screen, I would just go second quit, clear, 6 parentheses, 2 squared minus 24 parentheses 2 plus 8. And that's going to give me the y-coordinate as negative 16. The alternate way I could have gotten the negative 16 is graph the function y equals 6x squared minus 24x plus 8, graph it, and then plug 2 into the original function as opposed to in the derivative. So I'd go second calc, leave my number 1 on value, type the number 2, it's going to give me negative 16. Using the option 1 gives me the y-coordinate of a point. If I take the x-coordinate and plug it into the derivative, which I didn't have to do here, but if I went down to number 6 and plugged 2 in for x, I'm going to get 0 because 0 is the slope. But I already knew that was the slope. So now I have both the x and the y-coordinate of the point and the slope. If you remember the shortcut, you can get the answer to this quickly, but I'll pretend I didn't remember the shortcut. So I'm going to use the y minus y1 equals m times x minus x1 strategy to get the equation of the line. So I'm going to go y minus negative 16, that's the y1, equals m, which is 0, times x minus 2, because x1 is 2. The right-hand side comes out to y plus 16. The left side comes out to y plus 16. The right side comes out to 0. And then I'm just going to minus 16 from both sides. I'm going to get y equal to minus 16, and that's my answer. And I know that in section 2.4, that's what we did. When we were finding equations of horizontal tangent lines, what we did is we just found the y-coordinate of the point, and we just threw that in the answer. That wouldn't work. That only works when the slope is 0, or equivalently when the tangent lines are horizontal. In the last problem, because the line wasn't horizontal, it had a slope of 17, I was stuck doing the y minus y1 strategy. All right, so those are two problems. We'll just keep chugging through this. We're already 20 minutes into the video. 7 and 8, they're set up So I don't really need the product rule, but it says to use the product rule, so I'm going to use it. The product rule involves me doing kind of two pieces, and it needs multiplication. And the factors that are being multiplied are 3x minus 1 times 5x plus 6. So to do y prime, I need the derivative of 3x minus 1 times the 5x plus 6 unchanged, plus the derivative of the 5x plus 6 times the 3x minus 1 unchanged. The derivative of 3x minus 1 is easy. The derivative of minus 1 is 0. The derivative of 3x is 3. So for this derivative, I'm just going to write 3, and I'm not going to leave the 3 in a parentheses, although you could put it in a parentheses. I'm going to leave the 5x plus 6 there. Bring down my plus sign. Do the next derivative. The derivative of 6, since it's a constant, is 0. The derivative of 5x is 5. So the derivative of 5x plus 6 is just 5. And I leave the 3x minus 1 alone. There aren't any common factors. When we were doing the product rule, we cleared the parentheses. So I'm going to clear this parentheses and get 15x plus 18 plus 15x minus 5. That's just multiplying the first parentheses by 3, second parentheses by 5. Now I'm going to combine like terms and stop. So I'm going to add up this 15x and that 15x and get 30x, and take this 18 and minus 5 and get plus 13. So the best answer for number 7 is y prime is 30x plus 13. 8 is similar. I almost think 8 might be easier, but it also wants me to use the product rule, which means there must be a multiplication somewhere in the problem, which there is. So for 8, product rule again, y prime equals first the derivative of 4t squared times the 5t plus 3 just unchanged, plus the derivative of 5t plus 3 times the 4t squared unchanged. The derivative of 4t squared is just 8t. You multiply the 2 times the 4 and get 8. You lower the exponent by 1 and get 8t to the first. So the left half, you get 8t times 5t plus 3. The derivative of this next parenthesis, the derivative of 3 is 0. The derivative of 5t is 5. So the next piece, you get 5 times 4t squared. Now I'm going to clear the parentheses and combine like terms. So I'm going to get y prime equals 8t times 5t is 40t squared. 8t times 3 is plus 24t. 5 times 4t squared is 20t squared. I'm going to combine the like terms, the 40 and the 20t squared, and get y prime equals 60t squared plus 24t. This is perfectly okay for an answer. You get full credit if you stop there on a test. There's an obvious common factor. They both have a t. Both numbers are divisible by at least 6. So if I factored out a 6 and a t, I'd write a 6t and then a parentheses, and from here I'd be left with a 10t. And 24 divided by 6 is 4. It means I could have divided out a 12. Let me do better. I'm going to factor out a 12t because both the numbers are 60 and 24 are divisible by 12. If I factor out a 12t, 60 divided by 12 is 5. I had 2 t's, I took 1 t away, I'm left with a t. Bring down my plus sign, 24 divided by 12 is 2. I had a t, I factored it out, I don't leave myself with a t. This would be the best answer. So pulling out common factors is something we kind of consistently did, and it couldn't hurt to do. Alright, I'm not sure if the video's got a hiccup. I have a new machine in my office because my old video recorder broke. And this one stops at a different point. I haven't learned when it stops yet. It's going to stop real soon, so there's going to be a glitch somewheres. 9 and 10 want me to use the quotient rule. And the quotient rule is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So I'll start to do that. I'm going to write k prime of t And I need to put the denominator in a parentheses because it's a binomial. So for the denominator part, I'm going to write 2t plus 9. And then the derivative of the numerator is the derivative of 3t minus 5. The derivative of minus 5 is 0. The derivative of 3t is 3. So this is going to be 2t plus 9, which is the denominator, times 3, which is the derivative of the numerator, and then a minus, and then the next thing I get is the numerator, which is 3t minus 5. I need it in a parentheses because it's a binomial, times the derivative of the denominator. For the denominator, the 2t has a derivative of 2, the 9 has a derivative of 0, so it's just going to be times 2. And then all over the denominator squared. Now I'm going to clear the parentheses in the numerator. Probably going to help if I have this 2 written on that side. It'll make it easier to see the clearing of the parentheses. So now I'm going to go k prime of t. I'm going to leave the denominator in its form of 2t plus 9 squared. And in the numerator, it might help if I have the 3 over here as well, because it's easier to see the clearing of the parentheses. So I'm going to go 3 times 2t is 6t. 3 times 9 is 27. Minus 2 times 3t is minus 6t. Minus 2 times minus 5 is plus 10. The 6t's cancel in the numerator. I add the 27 and the 10, and I'm going to be done. So I'm going to get k prime of t is 37 over 2t plus 9 squared. This is the first time all summer my videos went more than 25 minutes. I don't know what's up, but we're at 27 minutes and it hasn't hiccuped yet. So hopefully it's working still. 10 is another quotient rule. Again, for a quotient rule, I need to take the denominator, multiply by the derivative of the numerator, minus the numerator, times the derivative of the denominator, all over the denominator squared. And the denominator I never FOIL out. So that's the generic setup. Now I'll do the derivatives that I need to do and kind of write them where they might be better helpful. So I'm going to leave the 3y plus 4, and the derivative of 2y is just 2, and I'm going to write that before as opposed to after the parentheses. And then I bring down this minus 2y. The derivative of 3y plus 4, the derivative of 4 is 0, the derivative of 3y is 3. So that second piece is 2y times 3, and then all over 3y plus 4 squared. Now I'm going to do the multiplication in the numerator and combine like terms. So I'm going to get f prime of x, f prime of y equals 6y plus 8 minus 6y over 3y plus 4 squared. 6y's cancel, and I get an answer, f prime of y equals 8 over 3y plus 4 squared. Video's still going. 11 and 12 are the chain rule, and I'm going to do the shortcut to the chain rule as opposed to doing the composition of functions strategy, which I think is a little bit harder, but it's more accurate. And that's not any more accurate, but it's, I don't know. It's just maybe better. So shortcut for the chain rule. Use the chain rule when you have a parentheses with an exponent. First thing you do is you bring the exponent out front, and you take the exponent and lower it by 1 and leave the contents of the parentheses unchanged, and leave myself some room. And what's going to go where I have that room is the derivative of the contents of the parentheses. So I did it just like the power rule. I brought the exponent out front, I lowered the exponent power rule. There it does, it finally clicked over. And now, to finish this up, that's where I left the space, I have to multiply by the derivative of the contents of the parentheses. So the derivative of 5x squared is 10x. The derivative of minus 3x is minus 3. The derivative of 2 is 0. This is probably the best answer. If you wanted to, you could multiply through by 4, the first parentheses. You can't multiply into the second parentheses because you'd have to clear the exponent first. So you can't really go any further than this. This is actually a better answer because it's more factored. But what I have written under it is it's okay. It's not really much worse. But they're, just a small step different from each other. All right, so that's better. This is okay. Both I used a shortcut for the chain rule. 12 also wants me to use the chain rule, but I need to have an exponent in order to see the chain rule. And so I'm going to rewrite this. Any square root problem can be written with an exponent of 1/2. Now I'm going to use the chain rule. F prime of x equals, I'm going to bring the exponent out front, leave myself some room, and lower the exponent by 1. And when I lower the exponent by 1, I'm going to take the 1/2 and I'm going to subtract 2/2. I'm going to get negative 1/2. And then next, in between the 1/2 and the 2x squared plus 1 to the 1/2 power, I take the derivative of this parentheses. The derivative of 1 is 0. The derivative of 2x squared is 4x. Almost ready to get done here. This 1/2 and that 4 from the 4x are going to cancel. The 1/2 is going to turn to a 1. The 4 is going to turn to a 2. That's going to give me f prime of x equals 1 times 2x, which is 2x, times 2x squared plus 1 to the negative 1/2 power. I need to make that exponent positive by creating a fraction. And in the denominator of the fraction, I'm going to get the exponent positive. And again, this would be an okay answer. But usually, if the original problem doesn't have a fraction exponent, I don't write the fraction exponent in my answer. And 1/2 power can always be turned back into a square root. And when I turn the 1/2 power into a square root, I don't really need a parentheses anymore. The radical is working like the parentheses. So this is probably the best answer for number 12. I think we're halfway done now. Maybe a little bit more than halfway done. 13 through 19 want me to do derivatives, and sometimes there's more than one way to do a derivative. So if you use a different strategy, you might get an answer that looks a little bit different than mine, but it probably is equivalent. So for 13, I'm going to use the product rule because there's multiplication. So to do the product rule, g prime of t, I have to do the derivative of 5t times the 3t plus 1 squared, just how it was given to me, plus the derivative of 3t plus 1 squared times the 5t, just how it was given to me. Derivative of 5t is easy. That just has a derivative of 5. So this is going to be g prime of t equals 5 times 3t plus 1 squared. This derivative, I bring the 2 out front, leave myself some room, and lower the exponent by 1 to 3t plus 1 to the first power. I leave the 5t. Where the room I left myself, I take the derivative of 3t plus 1. The derivative of 1 is 0. The derivative of 3t is 3. So I put a plus times 3 there. So this is going to give me, let me pull out the common factors before I do the multiplying. There's a 3t plus 1 and a 3t plus 1. I'm going to factor out a 3t plus 1. I'm going to be left with 1 there. And here's a 5. And there's a 5. I'm going to factor out a 5 as well. So rather than multiplying out and then having to refactor out, I'm going to get those obvious common factors out. From the first piece, if I factor out a 5 and a 3t plus 1, I'm left with one of the 3t plus 1s. It doesn't really need to be in a parentheses anymore. Eventually I'll drop that parentheses. From the second piece, I still have the 2 left. I still have the times 3 left. I factored out the 3t plus 1. I factored out the 5. I still have a t left. So that's what's left after I factor out. That barely looks like 3t plus 1, but it was supposed to be. So I'm getting g prime of t equals 5 times 3t plus 1. And then inside the radical, inside the parentheses, that's a 3t plus 1. You can drop the parentheses. This is a 6t. I'm going to combine the 6t and the 3t and get a 9t, and then plus 1. That's the very best answer to number 13. Anything more than this that you would do would be multiplying it out to make it less factored. So that would be the best answer. I'm worried a little bit about problem 14. So let me change it before you see it. And I'll change it. How about this? Y equals 2x times. Alright, this will forever be problem 14 now. So for problem 14, I'm going to do the same thing. I'm going to use both the product rule, because there's a multiplication, and the chain rule. So y prime is going to be the derivative of 2x times the x plus 5 cubed, unchanged, plus the derivative of x plus 5 cubed times the 2x unchanged. The derivative of 2x is just 2, so the first piece is going to be 2 times x plus 5 cubed. Second piece is a chain rule, so I bring the 3 out front. I lower the exponent by 1 and get 3 times x plus 5 squared. I leave myself some room, and where that room is, I take the derivative of the stuff inside the parentheses. The derivative of 5 is 0, the derivative of x is just 1, so inside that parentheses I put a 1, and then times the 2x. Just like the last problem, I have a common factor that I'm going to pull out before I get into multiplying. So this 2 and that 2 I'm going to factor out, and I'm going to factor out an x plus 5 squared, because when you have common parentheses, you take the smaller of the exponents. So I'm going to write 2 for the common factors of 2, and x plus 5 squared, because that's the smaller of the two exponents of the x plus 5s. And then I'm write what's left. 2's gone. The x plus 5 had an exponent of 3. Now it's going to have an exponent of 1. I'm not going to write the x, well, I'm going to write the exponent of 1, but I'm eventually going to drop it and just write x plus 5. And then after the plus sign, I'm left with the 3, the 1, and the x. Everything else I factored out. And I'll multiply those out. You can definitely show a little bit less work than I showed here. First piece I'm going to write x plus 5. Next piece I'm going to write 3x. And then I'm just going to add the 3x and the 1x there and get a 4x. So I get y prime is 2 times x plus 5 squared times 4x plus 5, and that'll be my final answer to 14. Fifteen's the derivative of an e, and to do the derivative of an e, you just multiply the derivative of the exponent of the e by the function how it's presented to you. So I take the e function how it's presented to me and write it down, and to the left of it I write the derivative of the exponent. In the exponent, the 4 has a derivative of 0, the 3x has a derivative of 3. So the derivative of problem 15 is just 3 times e to the 3x plus 4 power, and there's no way to simplify that. 16, I need a product rule because there's multiplication. So I'm going to write f prime of y, and then the product rule, first I have to do the derivative of the 2y minus 5. I'm going to multiply that by the e to the 3y without changing it, and then plus the derivative of e to the 3y times the 2y minus 5 how it was given to me. So f prime of y equals, the derivative of that parentheses is just 2. I'm not going to write the parentheses anymore. So my first piece is 2e to the 3y. The derivative of this, the derivative of the exponent 3y is 3, and then I keep the e part. So the derivative of e to the 3y is 3e to the 3y, and then I leave this 2y minus 5 alone. I'm not taking its derivative. The only common factor here is an e to the 3y that I'm going to factor out. So I'm going to get f prime of y equals e to the 3y times 2 plus 3 times 2y minus 5. This is ugly looking, parentheses inside parentheses, so I'm going to get rid of these parentheses and combine like terms. So I'm going to get f prime of y equals e to the 3y times 2 plus 6 minus 6y, 2 plus 6y minus 15, going 2 times 3y and 2 times 3 times minus 5, 3 times 2y and 3 times minus 5. Now I'm just going to combine the 2 and the minus 15 to a minus 13. And I get f prime of y equals e to the 3y times 6y, and then 2 minus 15 is negative 13. And that's the best answer for number 16. I think we have like 7 more problems. The word problems are still ahead of us, but they're not that bad. 17 is a division, so it's a quotient rule. To do a quotient rule, you have to take g prime of t equals the denominator, e of t, times the derivative of the numerator minus the numerator, t cubed, times the derivative of the denominator, all over the denominator squared. So I'm going to get g prime of t equals e to the t, and then the derivative of t cubed is 3t squared, so e to the t times 3t squared, minus t cubed times the derivative of e to the t. Any e has itself as part of the derivative, and then you add on the derivative of the exponent, but the derivative of the exponent is just 1, so I don't have to do anything else. So the derivative of e to the t is e to the t. It's going to help probably if I write the denominator without the exponent. E to the t squared means e to the t times e to the t. It's going to help in the canceling part of this. Now I'm going to pull out my common factor. In the numerator, there's an e to the t for both factors, so I definitely need an e to the t. And here's a t cubed, there's a t squared. I take the smaller of the exponent, which is t squared. So the common factor is both an e to the t and a t squared. To the left of the minus sign, I factored out the whole e to the t, I factored out the whole t squared, I'm left with a 3. After the minus sign, I had 3 t's, I took out 2, so I'm just left with t to the first power, which is t, and I took the e to the t out. So I don't need to write an e to the t, so I just have a 3 and a minus t. And then when I wrote e to the t times e to the t, it makes that canceling easier to see. And now I'm ready to write my answer. My answer for problem 17 is going to be g prime of t equals t squared times 3 minus t over e to the t. There are definitely things you can do with that parentheses. You can write that as minus t plus 3 if you want the t to be first. You can factor out a minus 1 if you write the t first, but this is completely fine. That's where I leave my answer for problem 17. 18 is just a derivative with a g, or an ln, and ln's are easy derivatives. All you do is take the argument and put it in the denominator of a fraction, and in the numerator you write the derivative of that. So to do this, g prime of t, ln's don't have ln's in their derivatives generally. So in the denominator, I'm going to get a 5t to the fourth, which is the argument. And in the numerator, you take the derivative of 5t to the fourth. 4 times 5 is 20. Lower the exponent by 1 and get t cubed. Then I'm going to cancel. And it might help if I do this for you. If I did 20t cubed over 5t to the fourth and wrote the t's without their exponents, you might see the canceling easier, because what you're going to be left with is the t in the denominator. I could have just subtracted the exponents and got a t to the first, and I knew that t had to wind up in the denominator because the bigger exponent was there. The 20 over 5 reduces to 4, and that 4 belongs in the numerator. The t's reduced to a single t, and that t belongs in the denominator. So the best answer for problem 18 is g prime of t is 4 over t. 19 is an ugly problem because it has the product rule and an ln in it. So it's going to be hard to simplify this. I'm going to write y prime equals, and it's product rule, so it's going to be the derivative of 4x times the ln of 3x plus the derivative of the ln of 3x times 4x. The derivative of 4x is just 4, and I'm going to leave the ln of 3x piece just how it was. And then the derivative of the ln of 3x, you form a fraction. In the denominator, you write the argument 3x. Above it, you write the derivative of 3x. The derivative of 3x is just 3. And I have this times 4x. This first piece doesn't reduce at all. The second piece, these 3's cancel. This x cancels with that x. I've canceled the entire denominator, so I don't need to write a fraction anymore. And the only thing I don't have a line through is that 4, and that's just a plus 4. And if I want to, I could factor out a 4. I'd say this is a good answer because the common factor doesn't have an x. It's not as big of a deal. If I do or don't catch that, I can factor out a common factor of a 4. But this is, this is an okay answer. This is probably better because I pulled out the common factor. But it's not that much better. When the common factor has an x in it, it's really important to pull that common factor out. When the common factor is just a constant without a letter, it's not that big of a deal to pull it out. All right, getting there. I think 4 more problems to go. So we've done a problem like this before in this video where we answered the parts A and part B, but for more easy functions. So part A, to find all values of x where the tangent line is horizontal, we find the derivative and we set the derivative equal to 0. So first step in part A is to find the derivative. It's a multiplication, so I need to use the product rule. So I'm going to take the derivative of x times the e to the 2x plus the derivative of e to the 2x times the x. The derivative of x is 1, so I get 1 times e to the 2x, plus the derivative of e to the 2x, which is 2e to the 2x, because for the e, you just bring down the e function, and preceding it, you put the derivative of its exponent. The derivative of 2x is just x, and then times this x. Pull out my common factor of e to the x, and I get f prime of x equals e to the 2x times a 1 from there and a plus 2x from there. Now I want to set this equal to 0, so I'm going to go e to the x times 1 plus 2x equals to 0. Then I go e to the x equal to 0, and we know that doesn't have a solution. And I do 1 plus 2x equal to 0. To do this, you minus 1 from both sides, and you get 2x equals to minus 1. And you divide both sides by 2, and you get x equal to minus 1/2. That's the whole answer to part A. X equal negative 1/2. To do part B, to get the equation of my tangent line, I need a point and a slope. The x-coordinate of the point is negative 1/2. The slope is m equal to 0. I need to get the y-coordinate of my tangent point by plugging negative 1/2 in for my x. So I'm going to go f of negative 1/2 equals negative 1/2 times e to the 2 times negative 1/2. That's going to give me negative 1/2. 2 and 1/2 are reciprocal, so they multiply to be 1 in general, but because they're opposite signs, they multiply out to be negative 1. I'm going to make the exponent positive by moving the e to the denominator. So I get the y-coordinate of my point as negative 1 over 2e. If I know the shortcut, I can write my answer to part B. If I don't remember the shortcut, I can go y minus y1 equals m times x minus x1. It's going to give me y minus negative 1 over 2e equals 0 times x minus minus 1/2. On the left side, I have a double negative, which goes positive. I get y plus 1 over 2e equals 0 on the right side, because 0 times anything is 0. And then I'm just minus 1 over 2e from both sides. And I get y equals minus 1 over 2e. That's my answer to part B. That's the equation of the horizontal tangent. I'm not showing the graphs like I did in the videos, but if you wanted to do the graphs to check yourself, that's fine. I'm just kind of just doing the calculus here and saving the making this video 3 hours as opposed to 1 hour. All right, so just how many? Just 2 more problems. They're both word problems, but they're easy-ish word problems. So 21 gives me, suppose that the cost in dollars to make X supersized candy bars is given by the formula. So this is a cost formula. The X represents the number of candy bars. C of X represents the cost of making that many candy bars. Part A wants me to find the derivative of a cost function, which is a marginal cost function, which will give me an ability to find the cost of producing the next candy bar. So to do C prime, the derivative of 3 ln of X, I could use the product rule. I don't really have to use the product rule. So I'm going to do the derivative on a separate sheet of paper. So C prime of X is going to be the product rule, the derivative of 3 times the natural log of X plus the derivative of the natural log of X times the 3, and then plus the derivative of 0.25, because that's a constant, it has a derivative of 0, so I won't write that part. Now C prime of X, here the derivative of 3 is 0, so I get 0 times the ln of X, and then plus the derivative of the ln of X times 3. To do the derivative of an ln, I form a fraction, I put the argument in the denominator, and the derivative of that argument in the numerator. So in the numerator goes the derivative of X, which is 1. And so now I have C prime of X equals, this piece is 0. Here I'm going to multiply the 1 and the 3 and get 1 plus 3 over X, which is just 3 over X. So I get C prime of X equals 3 over X. Now I'm ready to do the work here. Evaluate and interpret C of 5, which involves putting 5 into the original function. So C of 5 equals 3 times the natural log of 5 plus 0.25. And we can do that 2 ways. We can do it from the main screen on my calculator, going second quit, clear, 3 natural log of 5 plus 0.25, and I get $5.79 if I want to round that to 2 decimals, because it's money. I should probably round it to $5.08, should I say, if I round that to 2 decimals. The alternate way to do that is go y equals, do 3 ln of X plus 0.25, graph it, and then do second calc, hit enter on value, and then type 5. Gives you the same $5.08. So the evaluate, you get 5.08, and that's going to be the cost to make 5 candy bars. It's $5.08. Part B, evaluate, interpret C prime of 5. That's just going C prime of 5 equals 3 over 5, which is 0.6. So that's by hand. I could have done that from the main screen of my calculator. And on my calculator from the graph screen, if I did second calc and went down to option 6, dy dx, and typed in 5, it'd give me that same 0.6, although I'd have to round it because my calculator doesn't do calculus, it does some algorithm. So the plugging a number into the derivative of a cost function gives you the cost of producing the next one. So the cost of producing the 6th candy bar will be 0.6 or 60 cents. I'm going to write it as $1. I'm going to write that in a nicer form, dollar form with 2 decimals and a 0 in the dollar position, but it's okay if you just wrote it, said 60 cents. All right, last problem. I think I have 4 minutes to do it, so I'm going to try to do it. So this is a profit function. Bob's Hacky Sack Company determines a profit for producing and selling a certain hacky sack can be modeled by, gives me a function, gives me a value, a range of x's that it's good for. X is the number of hacky sacks, P is the monthly profit. Determine the derivative of the profit function. So to do the derivative of the profit function, I multiply the 2 by the negative 0.001 and get negative 0.002. Lower the exponent by 1 and get x to the first. Then I take the derivative of 7x, which is 7, the derivative of minus 800, which is 0. So that's the marginal profit function. I'll use that when I do part C. B, interpret P of 1,000. To do P of 1,000, I'd go P of 1,000, and I'm going to do this from my cheat screen. I'm going to go, it'd be negative 0.001 times 1,000 squared plus 7 times 1,000 minus 800. And I don't care to do that on my calculator, so I'm going to, on my y equals screen, go y equals and type this negative 0.001 x squared plus 7x minus 800. Make my window handle 1,000, so I need my x max to be bigger than 1,000. I'm going to make my x max go to 1,200. I don't care that I can't see the graph. Now I can get what this equals to by just going second calc, hitting enter on value, and typing the number 1,000. And I get $5,200. So if I did this string right here on my main screen, I'd get $5,200, and that's going to be the profit from selling. You might not even know what a hacky sack is. We used to play those when I was in college. I never was very good at them. So that's the best I could do for part B, kind of speeding it. And then for part C, to do P prime of 1,000, I could just go like this. P prime of 1,000 equals negative 0.002 times 1,000 plus 7. I could do that from my main screen. So second quit, negative 0.002 times 1,000 plus 7. I get 5. Let me do that from my graph screen. Go y equals, graph it, then do second calc, go down to option 6, dy dx, type in 1,000. You get that same number 5, and that's going to be the profit we earn from selling the 1,000th and first hacky sack. So I got a few seconds here. So the profit from selling the 1,000th and first hacky sack should be $5. All right, I think my video is going to end, so I rushed it a little bit there at the end. Hopefully it all worked out okay. But if you can do all the problems on this review, you should be spot on ready for the test. If you can't do them all, come visit me and I'll try to help you so you can do them all and do well on the test.